Hi friends, now we will start discussion on the topic residue upgradation. This is the part 2 of residue upgradation. In the part 1 we have discussed how the vacuum residue can be upgraded to liquid fuels which is and how to make the products more cleaner, and basically we have discussed on the solvent deasphalting process, and in this class we will discuss on Visbreaking, delayed coking and gasification. If we think the term Visbreaking, it itself indicates the viscosity breaking. So, in this process we will apply heat and the vacuum residue will be converted to lighter fractions with lower viscosity than the VR, and it will also have another part that is more viscous part, that the residue, and that can be processed further through the delayed coking. And in this viscosity breaking process we will be applying moderate condition, so that the asphaltenes and resins which are available in this will not convert into coke. So, moderate conditions is needed in this method as our target product is the liquid product or lighter products with lower viscosity, and this process can give us hydrocarbons like LPG, naphtha, gasoline, heavy gas oil, etc. And by this method we are getting some lighter from the residual part. So, if I think about our fuel oil, so the blending of fuel oil is reduced. So, the oil which is produced through this process that can be used as fuel oil, and the mild operating conditions, as I have mentioned, it is required because the materials which are available in the residue is susceptible to heat, and in this method allowable conversion to gasoline is lower due to fuel oil stability requirements. So, this is about the basics of Visbreaking process. Now, we will see the mechanism, what actually happens. As you have discussed that Visbreaking is the thermal treatment. So, in this case cracking will take place. So, the mechanism will be based on free radical, just like the thermal cracking we have discussed in the previous classes. So, we will be having here 3 steps. One is initiation, another is propagation, and then we have termination step. So, for example, we have one initiation step, says C6H14. So, that will be producing C2H5 and C4H9 dot. So, these 2 radicals, free radicals are produced. One is lower molecular weight, another is higher molecular weight with respect to this one. Now, this is initiation step. Then these free radical productions will propagate and more number of free radicals we will get, and then ultimately those will combine and it will be terminated. So, C2H5 which we are getting here, that can again react with C6H14 and it can give us C2H6 hydrocarbon, lower hydrocarbon, and again C6H13 another bigger free radical. So, this C4H9 free radical can give us again react with C6H14 and give us C4H10 plus C6H13 free radical. So, we are getting basically lower molecular weight hydrocarbon and the higher free radicals. So, those C4H9, this can give us C4H8 plus H free radical. So, this free radical again giving us some hydrocarbon and giving us some free radical, in this case H, in this case C3H6 plus CH3 dot, and then C2H4 and C2H5 dot. So, there are possibilities of production of number of hydrocarbons, types of hydrocarbons, and also the free radicals of lower size. So, this similarly C6H13 can give us C4H8 plus C2H5 dot plus many other products. Then in termination the free radicals can add with H dot and then it will give us C2H6. So, to another free radical CH3 dot it can give us C3H8 and it can CH3 dot plus H to CH4. So, we can get some gas also in this process and these are all gas molecules. So, LPG type of material we can get from the Visbreaking process. Now, we will see the process flow sheet of the Visbreaking process. So, what we need? We have to apply heat. So, what will be happening? In the previous class we have discussed that molten phase and asphaltene phase, resins and asphaltene are dispersed in the molten phase. So, by the application of heat the molten phase will be broken and asphaltenes will settle. So, that is the mechanism. So, we have to apply heat and we can apply heat in two mode, one for a very small period and relatively high temperature and another is relatively lower temperature and for a longer period. But whatever may be the mode we apply, but basically we need one furnace. So, we have to heat it here and then we have to flash it. So, we have to flash it means we have to use this in high pressure. So, high pressure at furnace that the product pressure will be reduced and then it will go to flash chamber and from flash chamber it will go to the fractionator and from fractionator we will get different products, gas and liquid products here and ultimately the tar will come here for further distillation and it is another vacuum fractionator it can come. So, in the vacuum we will create some vacuum and we will get more heavy gas oil in this case and the rest will be vacuum flash tar and this will be the feedstock for delayed coking. Now, as I told that there will be two mode of operation, one is very relatively longer period and lower temperature. So, in this case furnace and fractionator we put one soaker drum. So, soaker drum gives some time at relatively lower temperature for the conversion process. So, initially we preheat the feed here, the initial ambient temperature to some preheated temperature, then it is coming to furnace. So, it is heated further and then for a very small time in the furnace it stays and then it goes to soaker and relatively longer period it stays here and then it goes to flash drum and fractionator and in this case the soaker drum is optional. Otherwise we can use here some coil Visbreaking, there is no soaker, coil Visbreaking is there from furnace it is through the furnace coil for small span of time relatively higher temperature. So, that way also some fractionations will be there and we will get different products, but the products may vary in their quality and the relative amount may change to some extent. So, in this case the furnace inlet temperature is normally 305 to 325 degree centigrade here and then pressure is 15 to 40 bar and then outlet temperature when it is coming here it is a 480 to 500 degree centigrade and pressure reduction is there 2 to 10 bar. So, residence time is 2 to 5 minutes and steam injection is 1%. So, 1% steam is injected in this furnace. So, this is the Visbreaking process and as you have discussed that soaker drum helps to reduce the time in the furnace. So, temperature and pressure maintained at soaker unit is around 440 degree to 460 degree centigrade and 5 to 15 bar with 20 to 30 minutes residence time and preheating of the feedstock that 335 degree centigrade is done by using Visbreaking tar. So, this preheating which we are that is done basically this Visbreaking tar which is obtained, some part of it is used for heating this and as I told that there are two mode, one is soaker mode, another is your we have your coil mode. So, soaker mode Visbreaking process is relatively low temperature process with high residence time. So, here we have told that 20 to 30 minutes. So, it is around 1200 to 1800 second, whereas in coil mode this is 100 to 300 second. So, in the soaker mode of Visbreaking, two stage conversion we get, one minor degree of conversion of short period in the furnace and majority conversion takes place in the soaker unit for predetermined extended period, that 20 to 30 minute. As we are able to perform the conversion at lower temperature, so we can save fuel consumption. However, decoking in soaker unit require more equipment and handling cost. So, one way we are using less energy, but we are also facing some other problem that decoking in soaker requires more equipment and handling cost. So, this is the drawback, and this drawback, the coke formations in the soaker unit, that can be reduced by using some internals. So, if there is some back mixing in the soaker, then there will be more coke formations, but if you can reduce the back mixing, then the coke formations will be reduced. So, that way internals has been used. So, internal helps to reduce the coke formations in the soaker, and application of soaker internals satisfies these conditions and controls stability of products. Now, we will compare the different soaker with internal and without internal. What will be the difference between these two processes? So, if we compare the temperature, then we see 420, 420, in both the cases temperature is similar, but if we think about the conversion, then we get 2.90 percent of the liquid fractions at 150 degree centigrade. So, the liquid with the boiling point of 150 degree centigrade is 2.90 percent, whereas it is for internal it is 4.12 percent. So, more liquid we are getting here in case of soaker internals, soaker with internals. And then kinematic viscosity, if we think, then it is 248.43 CST, whereas it is 230.67 CST. So, viscosity is lower in case of soaker internal, because it is preventing the coke formations and back mixing in the soaker unit. And then stability, both are stable. So, that way it is very clear to us that if we use the soaker internals, then the quality of the product will be improved. Next, we will discuss on the delayed coking. So, the term indicates that coking will take place and it will be delayed. That means, there will be some arrangement, some more time will be given for the coke formation. So, as we have discussed in the Visbreaking part, that application of it breaks the molten phase, and then we get the separation of the asphaltenes from the colloidal suspension of the vacuum residue or residual part. So, here also the same mechanism will work. If we apply heat, then the molten phase will broken, and again the asphaltenes and resins will precipitate, and then we will get the coke. If we get sufficient time, so that part will give us coke. Another type may also be possible, that when we are getting the at higher temperature, if we increase the temperature, we will be getting more vapors from it also, and then that vapors may, if contains more aromatics etc. So, those will be polymerized, and if some condition is maintained, it can also give us coke. So, coke formation by both ways, by the first one, that is cracking of the moltens, and then the breaking of the emulsions and settling of the asphaltenes, as well as the production of aromatics vapors, and then the polymerization of those, and then condensation, and then also give us some coke. And these two cokes which we can get by these two mechanisms, the quality will be different. The asphaltene and resins which will produce the coke, that will be amorphous in nature and not of that high quality, but when the aromatics are condensed and polymerized and condensed and gives this product the coke, that is crystalline in nature and having some good properties, and it is considered as premium grade coke or needle coke. Now, we will see how to get it. So, this delayed coking technology, particularly for the needle coke production, is an art and a combination of art and technology. And already this delayed coke technology is an open art, it is known to everybody, but companies do license technology emphasizing coke furnace, special processing modes and operations. So, these are the area when the company varies from one to others among the technology licenses, and they have more focus on these areas. And in this case, generally two types of reactions can take place. One is your primary reactions and another is your secondary reactions. So, primary reactions is your decomposition of large molecules to smaller molecules, and then active compounds from the primary cracking reactions further crack or react to form other compounds or polymerize to give heavy products. Already we have discussed, and two types of mechanism also we have discussed. That is, one mechanism was for asphaltene precipitations and another was polymerization and condensation of aromatic compounds. So, it is very clear to us, if our feedstocks has more aromatics, then it will be giving better quality coke, and this type of coke is called needle coke. This term applies because the particles appear in the form of needle, in the it is a crystal structure it has, and the crystals appear like needles. So, that is why it is called needle coke. And we see what are the typical feedstock for this vacuum residue delayed coking. So, for delayed coking, the typical feedstock is vacuum residue. Atmospheric residue can also be used in some cases, and typical feed composition, if we see 6% sulfur it contains and 1000 ppm metals and CCR 20 to 30%. The CCR Conrad's on carbon ratio, higher the CCR value, obviously we will get higher coke. And what type of feed we will use, that will influence the product quality. And what type of products we can get through this delayed coking? We can get gaseous products, we can get liquid product, and we can get solid product. So, gas products which we can get, that is a coker gas that contains C3 C4, and this is recovered as LPG, and lighter can be used as fuel gas. And then liquid part can contain naphtha or heavy liquid products, gas oil. So, naphtha and gas oil, these two products we can get from this delayed coking, and this naphtha contains high olefin content and usually sent to the hydrotreating units in the refinery for stabilizations. In the previous slides, we have discussed the mechanism and we have seen that olefins are formed. So, those olefins are present in it. So, it requires more hydrogenations and sent to hydrotreating units in the refinery for its upgradation. And heavy liquid products, that is gas oil, we are getting from it, that is sent to catalytic cracking units where the valuable transportation fuels like gasoline, diesel and jet fuel can be produced. So, this is our liquid product, and solid product we can get different types of coke. So, coke may be of sponge coke, it may be of short coke, and it may be of needle coke. So, here we see needle coke. So, this is a crystalline structure, whereas the short coke and your sponge coke, we are not getting any crystal structure here. This is a sponge coke, spongy appearance, and this is a very small particles we are getting here for short coke. So, these among these three types of coke, these two coke, that is your sponge coke and short coke, those are not of that high quality, and those can be used for the production of electricity in combustion or in gasification plant. And then this needle coke is superior quality, premier grade coke, and it, apart from these thermal applications, it has more attractive applications, that is as electrode. So, it can be used as electrode because of its some specific properties. So, you see the characteristics of needle coke. So, volatile matter is less than 0.50% and then ash content is less than 4% and sulfur is less than 0.8% and density is greater than 2, the density is around 2.1 gram per ml. But this is the property which is most important for needle coke, that is CTE, coefficient of thermal expansion into 10 to the minus 6 per degree centigrade, it is 1.25. So, that is 1.25 into 10 to the minus 6 per degree centigrade. Because of this low CTE value, it is used as electrode, and needle coke production, whether the needle coke will be produced or other type of coal will be produced during delayed coking process, that will depend upon some factors. One is your feed quality and other is your operating parameters. So, more the aromatic contents in the feed, it is expected that the needle coke will get and the quality will also improve. And operating condition is also very, very important. As I told that delayed coking is also a blend of art and technology. So, in this case also needle coke quality can be improved by the practice or maintaining the operating parameters. Now, we will see the delayed coking process flow sheet. So, here we have some feed. So, we are giving some feed here. So, this feed, it is going to heater, it is heated up. So, it will be taking, the cracking will take place here, where we are putting heat here. So, heated up, then it is going to coke drum. So, in this heater also we add some amount of steam. So, steam is also added here. So, steam and a small amount of steam, and then residue is equal to VR. So, VR and this it is heated and then it is going to coke drum. So, high temperature here and here pressure is applied and then longer period the coke stays here, that is it is called coke drum. So, when it is after heating the VR and steam, it is going to this the coke drum, it is remaining here under high pressure at high temperature, then vapors are going out, then it is going for the fractionation. So, after fractionations we will get different products, we can get gas, we can get unsaturated naphtha here, and we can get some middle product also. So, gas oil stripper, and then we will get steam, and we will send steam here for its heating, and then we will get gas oil. So, that way we are getting gas oil here, and we are getting some fresh feed also we are adding in this case. So, fresh feed and this vapor which is coming, it is fractionated and the bottom part is again taken here. So, this is the feed, mixed feed actually. So, it is taken and it is sent to the heater and then it is going to coke drum, and then it is the vapor pass and it is condensed, and then we are getting different products. This is for liquid and gas recovery from this, but we getting coke from this coke drum, we will get the coke. After certain time we will collect the coke from the coke drum. So, this is the process for the delayed coking, where we can get coke, we can get gas, and we can get different types of liquid. Now, how we can change the distribution of this product, because unlike Visbreaking, in Visbreaking our main focus was to get more liquid, and here our focus is also positively to get liquid and gas as well as the coke also of premier quality coke, that is of needle coke. If we can get needle coke, then this process will be more economic. So, that is the one of the main objective of the delayed coking unit. So, what are the factors that will influence the quality of different products and its relative distributions of the product? That the some operating variables are transfer or coke drum temperature. What is the coke drum temperature I am maintaining, that will influence how much gas is produced, how much coke is produced, how much liquid is produced, and what is the pressure, that also influence, and recycle ratio, that means that I have shown you that we are adding some fresh feed and then we are taking this one. So, fresh feed and VR, how we are taking that composite feed and primary feed, that is the ratio is called your recycle ratio. So, that also influence the quality of the products, and the reaction time, how much time I am giving in the furnace and how much steam is added. It has been shown that if we increase the drum temperature, then coke yield decreases, because more cracking takes place and the more lighter parts goes off, and if temperature is too low, then coking reaction do not happen. So, we have to select an optimum temperature in coke drum, and then very high temperature makes the coke removal difficult from the drum, and temperature controls the volatile combustible matter content of the coke products. And then if we change the pressure of the coke drum, if we increase the pressure, then we may get more condensation of the vapors into the coke. So, coke yield will increase, but if we reduce the pressure, then we will get more liquid product. So, decrease in coke drum pressure reduces coke yield. So, some data is given here. Each 0.5 kg per centimeter square pressure reduction in drum increases liquid yield by 1.3% by volume and cut in coke yield by 1.08% of fresh resid feed. So, this is some data which is available in literature. Then for making the premium grade coke, the coke drum pressure should be high. It improves coke quality and CTE and electrical resistivity. So, when we are increasing the pressure, one way we are getting the more coke, as well as the quality of premium grade coke is also better. And increasing recycle ratio increases coke make and improves properties, because it lowers the asphaltene in the feed. More fresh feed we are using, that means the asphaltene concentration is reduced. So, that is why quality of the product improves. It also reduces coke deposition in coil. Now, we use some steam. What is the role of steam? Steam in the heated tubes prevents coke formation. So, coke formation does not take place, otherwise we have to shut down the plant very frequently. So, that way the steam helps, but steam does not help to get good quality coke. It has some negative impact on it. It has a bad effect on the coke yield and quality, as the stripping action that steam has on the residual oil on the coke. So, we can summarize that high density feed, then it will give us high carbon by hydrogen ratio, it will give high CCR, it will give high coke, less distillate and less gas, and coke yield is proportional to CCR. Now, delayed coking, if we think that first it is heated in the furnace, then it will go to coke drum, and then coke drum to vapor goes for fractionations, the upper part, and bottom part is we are getting the from the coke drum as a coke. So, this is a cycle. Coke drum, once it will fill, then we have to replace the coke from the drum, and again new drum has to be added. So, if we think about the whole process, it will require some time, and in one drum cycle the time distribution is provided in this table. You see here steam to fractionator, then steam to blow down, then depressurize, water quench and fill, and drain, unheat top and bottom, and cutting coke, and reheat, steam test purge, and drum warm up. So, you see the drum warm up requires around 4 hours out of 16 hours. Then major part is here depressurize, water quench and fill, filling of the coke drum, and then gradually it fills. At a time the coke drum is not filled, so it takes some time to fill. Then we give some time for cutting of the coke. Coke cutting also takes long time, and then other times are already say drain times also take some 2 hours, and others are given. Now, there are some empirical relationship to determine the coke yield. So, if we know the properties of the feedstock, then we can guess what will be the coke amount of coke produced during the delayed coking process. So, coke yield in percentage weight basis is equal to 1.6 into CCR value in weight percent. What is the CCR? Then 1.6 into that will be the coke yield, and gas, that will be, that is LPG, the 7.8 plus 0.144 into CCR value, and gasoline we can get this one 11.29 plus 0.343 into CCR value in weight percent, and gas oil will be 100 minus this coke minus gas minus gasoline. That way we can calculate by mass balance. Another formula, gasoline, how much we can get? 186.5 by 131.5 plus degree API into weight percent of gasoline, and then gas oil 155.5 divided by 131.5 plus degree API into weight percentage of gas oil. So, these are some expressions, empirical expressions which are available in literature for the predictions of different types of products of the delayed coking unit. Now, we are coming to gasification. Already we have discussed many things about the gasifications in the previous classes, and we have discussed that there are 4 types of gasifier, basically 3, one is fluidized bed and then fixed bed and entrained bed, and the transport reactor in between entrained and fluidized bed we have already discussed. And we have also discussed that entrained bed gasifier is more suitable for feedstocks which is less reactive. So, our pet coke and residue, all those are not of that high reactive, because it is coming the bottom product after high thermal treatment. So, these products, if we want to gasify, we need a reactor like entrained bed gasifiers to handle this less reactive feedstock. So, we see here VR and pet coke can be used to produce syngas through gasifications, and entrained bed gasifiers will be more preferable, and IGCC concept will be more attractive for the utilization of this coke produced through the delayed coking unit. Now, we will see some example of gasification plants based on this VR and pet coke. So, around the world there are number of plants, but this technology, gasification technology, is not very old one for pet coke. You see, it is started from 1995 and 2005 like this, and most of the 5-6 like this 1995, and around the globe in many countries the gasification of vacuum residue and pet coke is implemented and applied. And if we see all the reactors are basically Texaco and cell. So, Texaco and cell means entrained bed reactors for all the cases. Here only Roorkee MPG is used, but here it is oil and slurry. So, oil and slurry, oil is relatively reactive than the pet coke and residue. So, that is your Roorkee reactor is applied, but all other cases Texaco and cell. And here we see electricity, ammonia, hydrogen, steam, methanol synthesis, all have been implemented, and different types of syngas cleaning, Rectisol, Selexol, MDEA are used, and Rectisol is mostly used. So, here also you see all the pet coke. So, pet coke has been used widely for the production of electricity, but those of sponge coke and short coke type of coke, but needle coke is not processed through this route, it has better applications as electrode. So, that way in this part we have seen how the vacuum residue can be converted to different liquid parts, and the solid part also, that will be having more value than the conventional petroleum coke. So, up to this in this class, thank you very much for your patience.